So welcome to our weekly workshop. My name is David Raymond. I'm the director of the Virginia Cyber Range and the US Cyber Range. And so this workshop is going to be a continuation of our discussion of CTF challenge types. So last week, I'm pretty sure Tweaks talked about web challenges. And so this week, I am going to give a little bit of an introduction to reconnaissance challenges. And then I'm going to talk through some low point challenges. And you'll see that reconnaissance challenges are a bit of a crapshoot. I mean, well, we'll talk more about them here in a minute. And then next week, we will do an introduction to reverse engineering challenges. And so we'll talk about approaches to sort of the entry level reverse engineering challenges, right? So reverse engineering those challenges are generally pretty difficult. They assume some understanding of things like assembly language programming, perhaps, and usage of debugging tools like GDB or maybe a decompiler. But some of the very entry-level reverse engineering challenges are approachable by people with sort of a basic skill set. So we'll take a look at just some of those very introductory level RE challenges next week, and then sometime later on we'll delve more deeply into some real reverse engineering challenges. But onto my next slide here. So there's a CTF that goes along with these weekly workshops, and I've provided the URL here. So if you haven't already logged in or if you haven't already self-registered, then you can go ahead and do that now. If you're self-registered, then you can log in. And my bottom bullet there that says that you might see challenges added and removed each week as we talk about different challenge categories. So I sort of add and remove stuff when I want to highlight particular things in the challenge category that I'm talking about, and I moved some stuff around this week. So if you were already looking at reconnaissance challenges, and some of this stuff is different than you might have seen yesterday. Okay, so reconnaissance challenges. These are a bit of a catch-all. They often focus on general problem solving. They might even be sort of trivia challenges, or you might just sort of get this trail of clues and you're doing a bunch of Googling to find the answer. And those are fun and interesting challenges, right? So we do, cybersecurity professionals do a lot of what we call OSINT, which is open source intelligence gathering. So you have to be able to use tools like Google and other search engines to find information about people or places or things or whatever. And so to the extent that reconnaissance challenges are helpful for us to use those search tools better, then they're a useful thing to dive into. Other reconnaissance challenges cover other sorts of topics. For example, sometimes a CTF won't have a separate forensics category, but they might have a couple of forensics-like challenges, and that's something that you might see in a reconnaissance category, for example. Or if a CTF challenge author is creating a challenge and they're just not quite sure what bucket to put it in, like they're not sure if it's really a web challenge or a networking challenge or a cryptography challenge, they'll just say, well, I'm just going to call it a reconnaissance challenge because I'm not exactly sure where to put it. So reconnaissance challenges, again, are a bit of a catch-all, and we're going to look at some today, and I'll show you some specific tools that might be useful as you delve into some of these reconnaissance challenges in the future. And I've listed some tools here. So Google and other search engines, we'll see that Google is a great resource for some of these. I've also listed some command line tools in Linux, things like EXIF tool. So a lot of reconnaissance challenges are around things related to images, like a JPEG or a PNG or a GIF or whatever. And an EXIF tool is a tool to look at metadata related to image files. And so we'll see a little bit of that in my demo today. There's another tool called binwalk that I don't think I'm going to use today, but binwalk is used to identify when you have sometimes you can sort of merge different kinds of files together. So you might have an image file with some kind of an executable program that's sort of merged into it. And binwalk is a tool that will find different, combined binary files into a single file. If I don't think I have anything to show that off today, but I will definitely use it in the future to show you what that looks like. Another tool that might be useful in a reconnaissance challenge is the Internet Wayback Machine, or archive.org. That's a internet resource that archives old web pages dating back to like 1996 or 97. Goes back a long way, and sometimes in a reconnaissance challenge, you'll see questions about things that happened a long time ago, and maybe the organization that's referenced in the challenge won't, maybe their web page has changed drastically since 10 years ago, or maybe the organization doesn't even exist anymore. Well, fortunately, the Internet Wayback Machine archives all these old web pages. So if there's some fact that you might have to find about an organization from several years ago, you can go to archive.org and search on a domain, and you can find old versions of their web pages, which is pretty neat. And then another tool I've listed here, Shodan. So Shodan is a tool that lets you search things that are not web pages. So it works very much like Google, but you're not searching for web pages. You're searching for other things on the internet, like SSH servers and FTP servers and IoT devices and other non-web page services that are on the internet. People sometimes call the Shodan the search engine for IoT, because you can find all kinds of IoT devices. So those are all things you might see or you might find useful in reconnaissance challenges. With that, I'm going to jump right into it here and talk about a couple of these challenges from the weekly workshop CTF, and I've got plenty of time to delve into a handful of these. And I'll just start at the beginning here. So there's this one that's just a number, right? It's just a number. So 11,185,272. So I'm going to try that one first. And it says, what's next? 11,185,272. Well, I might try 11,185,273. Is that really worth 15 points? Maybe. Oh, no, that's not worth anything. Nice try. Given flag is not correct. Okay, so obviously there's more to it than meets the eye, right? It's not just the next number. So how do I even know what I'm looking for here? Well, the first thing I'm going to do is I'm going to go to Google, and I'm going to put in that number, and obviously that number must have some significance somewhere. Okay, and so what I find right away is that this number is related to these things called Mersenne prime numbers. Okay, so there's the first result I get is list of known Mersenne prime numbers, and then I have another one, Mersenne prime digits, and this one, so this one, it says Mersenne prime digits, and I see the number right here, 11,185,272. So that to me seems pretty lucrative. Let's see what I can find here. Okay, so this website is about Mersenne prime numbers, which is a specific type of prime number. And so here are these numbers. And so, so let's see if I can find on this page. There's Control F. No, there we go. I'm going to look for that number again. And it's, whoops. Sorry, I'm not getting to what I want here. All right, I'm going to copy and I'm going to paste, and it doesn't find that, so maybe I need to remove the commas. Okay, here it is. Okay, so this is, here's the number 11,185,272. It's the digit count of a particular Mersenne prime number. The Mersenne prime is 2 to the 371566667 minus 1. So that's the prime number. And the number of digits in that particular prime number is here. It's the thing in the challenge, right? So, okay, so what's next? Well, the next digit count is the next Mersenne prime number. So I'm going to copy that. And And we're going to see if that gives me anything useful. And okay, so that's the correct answer. Okay, so who cares about Mersenne prime numbers? You might be asking yourself, right? This seems a little bit esoteric for a CTF challenge. Well, turns out that prime numbers are very important in computer science, particularly in cryptography. So there are asymmetric cryptographic mechanisms that are very reliant on prime numbers. And so primes are important in InfoSec, primes are important in cryptography, and this particular challenge has to do with prime numbers. So eventually the students are going to learn more about primes, and maybe they'll think back to this. So that's that challenge, and hopefully people sort of tracked how I walk through it here. Okay, so the next challenge here, I'll just go on the list. Here's the next challenge: encoded message. Okay, so here's the message here. So I have this alphanumeric, not really alphanumeric. It's a bunch of it's all upper and lowercase ASCII characters with an equal sign at the end, and it says, what's that equal sign at the end all about? Okay, well that's a pretty good hint, right? I think we've seen something related to this previously in one of these workshops, but I'll just talk about this briefly. So if you're familiar with what this is at all, you'll know right away that it's a base 64 encoded message, and it's easy to recognize because it's got this equal sign at the end. And if I didn't know that, then I might just start Googling. I might just start Googling encoded message with equal sign, and right away this tells me it's base 64, and in fact this page is really helpful because it looks like it'll even let me it's trying to get me to sign up or something. Looks like it'll even help me decrypt this message. Okay, so a sequence of upper and lowercase alphabetic characters with an equal sign, with one or two equal signs at the end, in a CTF challenge or in some other computer science situation is very often a base 64 encoded message. And the reason it's got these equal signs at the end is because the output of base 64 has to be a multiple of 3. And if the base 64 encoding algorithm runs over a bit of text, and if the output is not a multiple of 3, then the base 64 algorithm is going to pad that message with either one equal sign or two equal signs. So again, if there's an equal sign or two equal signs at the end of a string of data like this, it's very often base 64. That does not mean that a message that does not have equal signs is not base 64 encoded, because it may just happen that the output of the base 64 algorithm was already divisible by 3, and so that the padding wasn't required. But if you see a thing that has an equal sign like this, it's very often a base 64 encoded blob. And I'm going to see if that's what this is. So here I hit decrypt, and I get a readable thing, right? It says it gets harder from here. So I'm going to copy that, and I'm going to paste it in. And I'm pretty sure that's the answer. So base 64 encoding and decoding is important. It's used in computer science frequently to encode data to send back and forth over network connections. So that's why base 64 is a thing. That's why you see it a lot in CTFs, because it's a widely used computer sciencey tool. Let's go on to the next one here, Joshua. This is just a trivia question, right? A classic 80s hacker movie was about a high school student hacking into a government supercomputer and almost starting World War III. The main character was based on a real person and even uses his first name. What is the last name and the inspiration for this main character? And I'm not going to delve into this challenge. It's just a trivia challenge, right? So you should be able to do this yourself. And classic 80s hacker movie. You probably know what that is already, but if you don't, I suggest you do a little searching around. You should be able to solve that with no trouble. Okay, the next one here, meta-analysis. Meta-analysis says you know what to do. And I know what to do. Do you know what to do? So this is a, well, it says nice K12. I'm going to click the link here and it downloaded nice K12.png. Okay, it's an image file. It's a PNG file. Here's my image. It opened on my computer. I have this thing called IrfanView, which is a really nice image viewer software. You can edit image files and do various things with IrfanView. Okay, so here it is, and let's see what I can do in IrfanView. So the name of the challenge is meta-analysis. So what I'm looking for is metadata in the image file, and in image files, the metadata is often referred to as EXIF data. It's just a particular format that metadata, that image metadata is placed in for digital images, right? So, and digital images have contained metadata since digital images were first a thing back in the, I guess digital images started in like started being commercialized in like the late 90s. You could buy digital cameras, late 90s, early 2000s. And so when you take a picture with your smartphone or with your digital camera, there's some metadata that goes along with the picture. It includes some interesting stuff that we're going to take a look at here in a minute. This is a PNG file, and when I look at it in IrfanView, I don't see the metadata. Depending on the file type, you may or may not be able to see it in a tool like this. I don't know. I'm not going to mess with it because I know a better tool to do this analysis. I'm going to do it at the command line. So I'm going to go to my command line, and I'm going to use a tool called. I'm going to use a Linux command line tool called EXIF tool. EXIF tool. So what it's called, EXIF. So that's EXIF. That's the again the format that this metadata on image files is stored in. And so the command line tool is EXIF tool. If this is not included on your Linux system, if you're using whatever Kali or Ubuntu or whatever, if EXIF tool is in there, of course you can use the package manager to add it. So you can just do an apt-get install EXIF tool. First, I need to see. Okay, it's this. Here's the file, nice K12.png. So I'm going to say EXIF tool. Nice K12.png, and this is the metadata stored on this image. And so so here's information about EXIF tool itself, right? Here's the EXIF tool version number 11.88. And the rest of this is metadata, right? So there's the file name, there's the file size, there's the file modification date and time. The access date and time, the inode change date and time. That's the last time I interacted with this file, which was like 2 minutes ago, right? It's 4:16 in the afternoon on today. Here's the file permissions, file type. It's a PNG. You'll see information in here about. Sometimes you'll see the camera that was used to take the picture. Sometimes you'll see. The latitude and longitude of where the picture was taken. It really depends on what data the camera is capturing, and it depends on the file type also. Some image file types have different metadata than others. If I look at this for a few minutes, go sort of line by line, what I run into here is this. There's this rights item here on the left, and here's what looks like the flag. It looks like the flag because it says flag and it has curly brace open 2020 NICE K12 curly brace closed. So this was a challenge that we created for the NICE conference, the NICE K12 conference a few years ago. So I'm going to copy that, and I'm going to go back to my CTF engine, and I'm going to paste in that metadata I pulled out of there. And there we go. Got my flag. So image metadata is a common trope in capture the flag contests, particularly in reconnaissance challenges. Why didn't I get my points here? Should I get points for that? Oh, what? It's not correct.
So the answer is actually within the curly brackets.
Oh, well, yeah, we should have used regular expression to make that work. Should have worked either way, so we'll fix that challenge. But here I got 20 points. Okay, here's the next challenge we got on the list here. This is another image file. It says where in the world, and here's a downloadable image file. So again, this is a picture of a Caribbean island, and I've got it open in OrphanView. And okay, so OrphanView for a JPEG image lets me look at some of the EXIF data right in OrphanView. So there's EXIF info here. There's a button here that I can look at the metadata, and then there's IPTC info, which is some other metadata format. I don't know what the IPTC stands for. So if I look at EXIF data here, you would think that there'd be like a lat long in here, but maybe there's not. Let's see here. Date time. This is when the picture was taken, 2017. Flash. See anything interesting here? We'll see a lat long. If there's a lat long, often with something like this, you see a lat long, latitude, longitude, and you can look up the latitude and longitude. Let's see, maybe I can look at the IPTC info. Let's have, it's all about searching through the metadata, right? Credits origin. Oh, here we go. Credits, it says credits / origin. And it has the city, it has date created, and then it has the origin, city, it has the city, Basseterre, sublocation, province, St. Kitts. Okay, so this is a city, Basseterre is a city in St. Kitts in the Caribbean. So that's the location. I don't know what the, I don't know if it's this or this. Let's try this. I think it's this. So this was even easier because if there, yeah, so that's the right answer. This is even easier than if there was a lat long, because if there was a latitude longitude, then I'd have to go to something like Google Earth or some other online tool to put in the latitude and longitude and find the physical location on the ground to find, you know, what the location is. But that one was fairly straightforward. Okay, 423. Maybe you do one more here. Steganography is the name of the challenge. So here we say that steganography is the practice of hiding data in seemingly innocent looking files. It is often most difficult just knowing when a file has hidden data in it. The attached PDF has hidden data. Can you find it? Okay, did we look at one of these before? Okay, so there it is, hello world.pdf. And if I open it, it says hello world, and I don't see anything else. Okay. So how do I see if there's hidden data in it? Well, I could yeah, here's my hello world.pdf. I could just do like strings, strings hello world.pdf. And look at that, boy, it just popped right out. It's right at the bottom. That was really easy. There's all the strings. So strings, we probably talked about strings before. Strings is a Linux command line utility that will take any file type and it will find all sequences of 4 or more ASCII characters, and it will spit those out to the command line, spit those out to the terminal. The default is 4 characters or more. I can change that default by there's a command line flag that I can use to make that either shorter or longer. So I can look for 3 or more characters, or I can look for 10 or more characters. That was really easy. I didn't realize it was going to be just show up right here at the bottom. A lot of flags, we've seen this a couple times today. A lot of flags have this flag the word flag and then an open curly brace and a closing curly brace. And so what I often do on a challenge like this is I would say strings, and then I would type that through grep, and I would say grep, flag, and open curly brace. And that's going to make it even easier, right? That's going to find the instance of this particular keyword flag, and then I only have one, then the answer just falls out all by itself. So here, if I copy this, I should be able to copy this and paste it in here. What am I doing here? There it is. It's not Chrome, it's in Chrome. I should be able to paste it in like that, and it should work. And if it doesn't work, then that's our fault, because we should have regular expressions that are okay. That gave me the points. So I'm going to take 3 minutes here to talk about why this challenge didn't work when I included the word flag, and this challenge did work when I included the word flag. I'm going to talk about that for 3 minutes. So, so if you recall, with the meta-analysis challenge, I had the word flag, then I had a curly bracket, and then I had the flag. And when I included that word flag with the curly bracket, this challenge didn't accept that answer. That's because we didn't. That's because the way this challenge was created, right? So here's me editing the challenge. We talked about editing challenges way back in maybe the second workshop in this series, several weeks ago. And when I put in flags, I can put them in as strings, or I can put them in as regular expressions. And this one is put in here as a string, right? So I have to match, when I have a string flag, I have to match this string exactly. I can't have any thing that is not this exact sequence of characters with nothing at the beginning or end, and everything has to be the same case, right? If I did this as a regular expression, now I have to know how to create a proper regular expression. And I'm going to do that here. So this particular regular expression says I can match this sequence of characters, and it can be that I put this IG, this delimiter at the end. What that means is the I means this can be case insensitive, so I can have either uppercase NICEK or lowercase, or a mixture of the two. So the match should be case insensitive. And the G says look for this sequence of characters anywhere in the data that's provided to the regular expression matcher, which is going to be whatever somebody types into that flag bar, right? And what makes this one more difficult is it's got a special character at the beginning. It's a hashtag. Nowadays we call it hashtags. In the old days we called it other things. But that probably has to be escaped, or this regular expression isn't going to work. And so I'm not going to get into this right now because it's a much longer conversation. But I'm just making the point that because this was a string flag in the challenge, now the person who's putting that in as the answer has to match that sequence of characters exactly, including case, can't have anything added to the beginning or the end. I'm not going to make that change right now, but if I go to this challenge and do the same thing, I'm going to open up the challenge and I'm going to go to the edit button. You'll see that this challenge, oh, look at that. This one, I don't like this one either. This one has two strings. It has one for this and one for this. Okay, so this is an old challenge. We've gotten better in our challenge creation. What this should really be is a regular expression. So we should just be able to get rid of both of these, call this a regular expression, and I got to escape the question mark. I'm going to confirm, and we'll talk a lot more about regular expressions in a future workshop. And I can't solve this again because I already solved it, but trust me, that would work. That would work even if whether I had the flag bit at the beginning or the end, it would work. Okay, I'm going to stop there. Any questions or comments before next time? All right, well, thanks. We'll do this next week at 4 p.m. on Tuesday, and we will do we'll just dip our toe into reverse engineering challenges and take a look at some very entry level ones. And then sometime later on, we'll get deeper into reverse engineering challenges. So thanks, everybody, and we'll see you next week.